Hello, welcome to this video. I'm going to talk about the mining of social media on COVID-19, big data infodemic in Indonesia, precisely. So this topic is about research that have been done on Indonesia and especially on the platform of Twitter that they talked about the text of Corona or COVID-19 in Indonesia. So the outline of this research and this topic, we have an introduction about the COVID-19, then cases of COVID-19 in Indonesia, then coronavirus infodemic, big data and text classification, cross-industry standard process for data mining, data and data sources, data preparation, modeling, manual labeling, and the reference of this research that I got for this video. An introduction about COVID-19, which the World Health Organization that declared coronavirus or COVID-19 disease as a pandemic in 2020. The pandemic status was due to the disease that was not an antidote to immunity and spread worldwide in various regions of the world unexpectedly that caused 10 million cases, 188 countries, and 500,000 death cases. These are the cases of COVID-19 in Indonesia, the cases of coronavirus. These cases were rated by the death, recovered and confirmed cases during March, April, May, June, and July. And this figure of the research was due to July 2020 of the research. Coronavirus infodemic is too much information, including false information or misleading information in a digital and physical environment during a disease outbreak, and this can cause confusion and risk-taking behaviors that can harm our health and can confuse the human beings on what is happening around the world. So, big data and text classification. So, what this research talks about and did is they basically came and gathered data from Twitter by the Twitter scrubber method, and they gathered these data. They understood these data and prepared this data by cleansing the data, case folding the data, parsing the data, tokenization and stemming, and used a few modeling or algorithms to classify the text by using naive Bayes, sport vector machine, and random forest classifier. And at the end, they evaluated this data. They classified these data and made it into a confusion matrix. Cross-industry standard process for data mining. The CRISP-DM process model provides an overview of the life cycle of a data mining project. CRISP-DM has 6 stages: business understanding, data understanding, data preparation, modeling, evaluation, and deployment. Data and data sources. The tweet data is taken by web scraping method, which is the process of extracting data from a website. The website in this case is the social media website Twitter, like we talked about, by using the Twitter scraper. The data taken is only tweeted in Indonesian with keywords Corona or COVID. The the data preparation we have is filtering, labeling, cleansing, case folding the data, parsing the data, tokenization, and stemming the data. And modeling, many natural language processing methods can be used to classify social media content. In this study, the research study, they used 3 models using random forest classifier, sport vector machine, and naive-based classifier. The data used to create the model uses the March tweet review data, which is assessed for sentiment manually. Sentiment value consists of three names: neutral, negative, positive. The positive and negative, the positive sentiment means that the sentence has words that contain more positive meanings, while the negative sentiment contains of negative meaning, and the neutral sentiment is formed because of number of positive meaningful words is equal to the number of negative meaningful words. The data set used to make the training model 70%, and the remaining 30% of the data is used to test the model and get an accuracy value from each of the classifying algorithms. And this is a representation, like a classification by date, and this is a tweet classification. So the 3 models that used to classify, they all produce confusion matrix performance measurement, and in this confusion matrix of each model, it showed that the best performance with the best value of confusion matrix on all labels, followed by sport vector machine, while naive-based classifier only has a good confusion matrix for neutral labels. And this is the random classifier, random forest classifier, sport vector machine classifier, naive-based classifier based on precision, recall, F1 score, and the sport. And it's all about the accuracy of the algorithms that they used. This is the reference that I got from, and thank you for watching this video.